Hello there, I'm Jean Weeb. Can you tell me all of the places where we can find water? Turn around to your neighbors and everybody quietly say one place where we find water. All right, I think some of you said some things like oceans, rivers, rain, wells. Did you say faucets, snow, fruit, meat, vegetables? Did you say in our bodies? Did anybody say in wood, in medicines? You're right. Almost everything has some water in it, doesn't it? Now tell me some places where, some ways that we use water when we're going about our everyday lives. Tell me some of those places. Yeah, we bathe in water, we drink water, we cook with water, we wash vegetables and other foods, we wash floors and clothes. We use water in a lot of different ways. Water is very important to us. And all over the earth, we have a lot of water. It's there for us to use. There's plenty for us as long as we take care of it. Water has tiny little parts called molecules, and those little molecules cling to each other like tiny little magnets. So the molecules at the water's surface cling with a force that is very strong. This is called surface tension. It's like an elastic or a magnet sticking to each other. This force, surface tension, shrinks as much as it can on the surface, and when it has shrunk as much as it can, pulled together as much as it can, it forms a sphere. We can see surface tension in some other ways too. I have a bowl here. I'm going to use my pile of straight pins here to see if I can get anything else into this little bowl of water. Let's see, straight pins. These are sharp, so be careful if you do this. Straight pins. No water is spilling. Oh, I thought it was full. Let's try a few more. Try two at a time. No water is spilling yet. Let's try a bunch. No water is spilling yet. Let's try a bigger bunch. See what happens. Thought that thing was full, but it's really holding a lot. I can go here. Let's get on there. Ooh, look what happened. Two of my pins are floating on the surface of the water. Surface tension can hold the weight of those pins. Even more can go. Oh, more are floating. Look what's happening. Let's try it two-handed. See if I can get any more in there. Ooh, it's jiggling, but it's not spilling. No water on my brown paper towel yet. Look at all of that bulk of pins that it's holding, and it still hasn't spilled. Wow. Amazing. Well, I've used up my pins and my bowl, evidently, still has room in it. Let's try some more water. This, drip, no spilling, drip, drip. Where's all of this room coming from? Wow, I thought that bowl was full and now it's got a whole package of pins. Now I'm adding even more water and it still is not spilling. What's happening here? Let me look at it from the side. There's water up over the top of the bowl. It's sitting up on the top edge of the bowl. Can't believe it's holding this much water. What's doing this? Surface tension has a lot of force. I can see the edges curving up and over the bowl. And it still has not spilled. More and more water is sticking to the top. That surface tension is really something. I wonder how high we can make this. It's already curving up over the top edge of the bowl. This is pure water right out of the tap. No water spilling yet. Let's try it some more. I can see the whole top curved edges up from around the rim of the bowl. My pins are still floating. The surface tension on the outside edges of the water pulls together like those little magnets we were talking about, and cling and pull like elastic until they're as tight as they can get. Wow! How many droppers have I used? It's still going. Water is really special. This is neat. Everybody remember surface tension. Strength should be called surface strength. Let's have another look from the side. Wow, you can see water right up over the top of the edge of the bowl. Let's try some more. Well, let's keep going. I wonder, whoop, whoop, there's a little bit of a spill finally. Finally we got it full and more. And the little needles floating and the curve of that water show that surface tension is a very strong force in water. It's only in water. I'm going to stick the edge of the paper towel into the water. What do you think is going to happen? What do you think? It's going to get wet, isn't it? The edge of the paper towel is going to get wet. When oh, look what's happening. I'm only touching the edge of the paper towel into the water, but look at the water climbing up my paper towel. Is that surface tension? Surface tension makes water stick to everything, including itself. So when water starts to climb, it's called capillary action. And the water keeps on soaking and clinging to itself and climbing up. Not with little feet, not with little talons like birds, not like animals, but it keeps going up. And if I leave, it's still climbing. If I still leave this paper towel like this, it'll soak all the way up there. You can try this and see how long it takes to get to the top, or how much water it will hold. Capillary action helps this water to climb up the paper towel. There are some very special things about water. That surface tension of water is useful in a number of ways. Now then, I have a tall container of bubble solution. This is, we bought some and there wasn't enough, so we also mixed some clear dishwashing liquid and a little bit of glycerin and some water. And you can make bubbles with anything that's round. Cookie cutters, jar lids. Let's see how I can do this. Love to make bubbles. Things come with bubble containers to make bubbles. I have one of these and it makes bubbles. And my husband made me this from a coat hanger. And if I dip that in there, it's not quite deep enough. Just want it to, whoops, come up to the edge there. Look at the bubble that makes. It takes the smallest surface, it shrinks as much as it can and covers the smallest surface. Can you see the bubble? It's clinging all the way up and down that line. Isn't that neat? Do this outside, it's better, or in the bathtub. Turn this pan over and put some very hot water. This is close to boiling. We're going to top that off so that it's completely full. Yep, that's what the pan is for, is spills. And I have some food coloring here, and I'm going to, this is still water, and I'm not going to stir it, but I want you to watch. When I drop some food coloring in there, watch what happens. Now there was the force of the droplets dropping, but the water is still. What's making this move all through that water? Water, even though it looks still, is not completely still because those teeny tiny little parts called molecules are constantly moving in there. The tiniest places are moving. And so they eventually will mix this color all through the whole water. Let me add some more just to make it really good and red. This is very hot water. I want you to see something that happens when hot meets cold. And Frank, would you lift, this is just a piece of plastic from a Cool Whip bowl. Can you lift that? And I'm just going to hold this hot thing in place. Can you lift that, turn it over, and try to put that rim of that jar over top of this? Keep that sealed as well as you can. If any spills, that's okay. We've got our pan here. And then, when it gets up there, now it has to get, yeah, your fingers are out. That's a good thing. All righty. Now then, I want you to watch what happens. Watch. The red is not staying in the bottom. The red is zooming up to the top. That hot water that was in the bottom zoomed up into the top and mixed. And I can see little waves of water coming down. I can still see water moving up, and I can still see the little waves of water moving down. And now it's mixing. But I want you to notice something. This is another special thing about water. And about air works this way too. Heat rises and cold sinks. We started out with very hot red water on the bottom and very cold clear water on the top. And when these were allowed to mix, they didn't just we had these as full as we could get them. And so they could have just stayed in place. But the hot won't stay in place when it has a chance to go up, and the cold won't stay in place when it has a chance to go down. So this is called convection. When heat rises and cold sinks, this is called convection. And it happens also with air. This helps our weather system. It helps us to have the precipitation that we need. Here is a replica of my refrigerator at home. And my freezer is of course, up here. So I want to show you something that I did. I put 3 glasses of water into my refrigerator. One with about 3/4 full of water, one about 3/4 full of vinegar, one about 3/4 full of alcohol, to see how fast they would freeze and how they would freeze, where they would start to freeze. And I closed the door after I put them in there, and I waited a little bit. And I waited about 15 minutes, and because my glasses were about this big, and it was quite a bit of liquid in there because I wanted a good picture to be able to see that would show up in this size photograph, I took a picture about every 15 minutes. So everything got colder. You can see the frost, the coolness forming, and ice crystals began to form on the surface of the water. You could see the little marks. The vinegar still looked cloudy at the bottom. The alcohol hadn't done anything yet. So I put it back in, closed the door again. Well, finally, I kept checking every few minutes. A thin layer of ice started to form on the top of the water, and the vinegar was very slushy at the bottom. You could see the little wisps of ice at the bottom of that. I'm going to leave that closed for a minute, let that work, and show you something here. I have 2 glasses of water and a couple of coffee filters and a couple of black markers. So I'm going to make a spot in the middle of each coffee filter with a water-based black marker, and I'm going to stick the little part that I cut down into the water. Now remember what happened when we stuck the brown paper towel into the water. Water climbed up it. Let's see what happens here. What do you think will happen? A coffee filter is pressed paper. I'm going to use a different kind of a black marker and make a spot on here also and put it in this other glass of water. And we'll let those sit and see what happens. Let's go back and check our freezing liquids again. We have a thin layer of ice on the top of the water. The vinegar is slushy at the bottom. The next time I checked it, there was distinctly ice on the top of the water. It's more solid. Nothing with the alcohol, and the vinegar's slush was rising up through the whole glass. These were glass glasses that I used. Now then, the water is covered by a solid layer of ice, still nothing from the alcohol, and the vinegar is completely slushy all the way to the top. I left it a little bit longer, then I checked it again. The water was covered by 1/4 inch of ice. The alcohol still hadn't done anything, and the vinegar was completely frozen. The water was still liquid underneath that 1/4 inch of ice. Now, water on the earth is exposed, the top surface is exposed to the cold and the wind. And that's where the ice forms. The ice layer forms at the top. But the surrounding, there is not exposure on the sides of a lake or the bottom of a lake, is there? And do you know what happens? Do you know what goes on inside the earth? Scientists believe that the center of the earth is very, very hot, molten material. So when you go several feet down into the earth, it's actually warmer. So when water occurs naturally, oceans, rivers, lakes, streams, ponds, the surface is the only part that gets exposed to the cold. If I left these glasses in here, this water would completely freeze. But if this were a lake, it wouldn't, because only the surface would be exposed to the cold, where in this refrigerator, the whole glass is exposed to the cold and would completely freeze. So let me show you how this helps some other living things. You know, while I'm here, there's nothing like a good drink of cold water. Delicious. Oh, look what's happening on our glasses. That black marker, when it's exposed to water, is separating into the colors that went into mixing it. Now this one was the Crayola marker, and this one was another marker. Different brand of marker. That's interesting. I wonder what that would look like with other colors. Now then, I want to show you what happens with fish. How convection helps fish. And I have a little shadow box here to show what happens in a river or a pond or a lake. Well, of course, those are populated by fish and frogs and snails and turtles, and living things are just all over the place there. When cold weather comes and touches the top surface of the water, that water gets cold. Can you see my little droplets of water here that are on strings? The surface of the water gets cold first. And what happens with cold stuff? It sinks. So those cold droplets of water, gazillions of them, sink and go down to the bottom. And the warmer water gets exposed to the cold. Well, this keeps happening, and water keeps moving from the top down to where it's the coldest. And it keeps going on like that, and the winter keeps getting colder, and winds blowing and all of that, and fish are swimming around in there, and frogs are hibernating. Other things have made their winter homes. But something very special happens to water, and water is evidently the only liquid. Remember what we just did in this refrigerator, that I did in my refrigerator at home. Water is the only liquid that does this, but just before it freezes, it expands and gets lighter and less dense. And so all that cold water that originally went to the bottom of the lake, river, pond, stream, ocean, whatever, now goes back up to the top. And that's where it freezes. So that cold water that originally, when it got cold, sank to the bottom, when everything gets to a cold enough temperature that something starts to freeze, that coldest stuff that has been going to the bottom starts to freeze, but it expands, becomes less dense, and goes to the top. And that's where the ice forms. Then the ice gets a little bit thicker and a little bit thicker and a little bit thicker, and forms a layer that is solid enough to provide insulation. And the water under it never finishes freezing. This insulation, combined with the heat that comes from inside the earth, provides unfrozen water no matter how cold it gets. Even in the Arctic, there is moving water underneath the ice. And the fish and the hibernating creatures that are down there are able to find food if they're awake, or stay alive if they're hibernating until spring when all of this melts and they can go on about their food hunting business. Convection saves the fish. This is no accident. If at the beginning it had not been done exactly this way, the very first time that it got cold enough for water to freeze, if it had frozen at the bottom, everything in the bottom parts of the water, parts of the earth, would have frozen and died. There would have been no second chance. Who do you suppose engineered all of this? Who has the knowledge and the power and the love to make everything perfect so that animals and we can live on this earth, can provide us with everything that we need, working perfectly? Think of all of the important things that we've said about water. It not only helps the fish, it helps us. Go out and see if you can find some more important ideas about water, about the things that live in water, about how water works. There are lots of neat things that you can do, books that you can find in your library that tell you more fun that you can have with water. But always remember that whatever we do with it, with water, with everything that we work with in nature, is one example after another, after a gazillion others, that show that God made everything perfectly. It's no accident. In Genesis 1, at the end of each day, God looked at what He had made and said, "This is good." You know what the word good means? It means perfect. So when God made it, He did it right the first time, and it has helped all of us ever since. So remember, when you're studying, when you're looking around you, when you're taking a bath tonight, when you're washing the dishes for your family, play with the water a little bit, and remember that this is another part of God's creation. Remember, God made it all perfect.